The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to empower techies. We believe sharing of knowledge is key to enhance our skills and grow us as a professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is money transfer through financial messaging. And our guest speaker for today's session is Mr. Parag Bise. He is Vice President at Nucleus Software Export Limited. Parag has about 25 years of experience in building software product and custom-made solution for BFSI segment, specifically in area of transaction banking, retail lending, expense management, financial reconciliation, foreign exchange, etc. Currently, he heads product engineering and transaction banking product at Nucleus Software. The major product suite Finaxia covers following products in its portfolio like Global Receivables, Global Payment, Global Liquidity Management, EFCM, Business Internet Banking, and Mobile Transaction Banking. So without any further delay, I introduce you all to our guest speaker. Over to you, Parag.
Thanks a lot, Gaurav, for your introduction. Good afternoon, everyone who joined this webinar. My name is Parag, as Gaurav mentioned. I'm working with Nucleus Software as Head of Product Engineering, Transaction Banking Products. While I'm working on this particular responsibility for the past 3 years, as such, I have an industry experience of over 25 years. Most of it is in delivering software products and custom solutions in the BFI segment, that is the banking and financial services segment. My area of interest is in creating state-of-the-art software products, especially for banks, because I have noticed that banks are usually the front runners in adopting technology as it becomes available. Having introduced myself, let us move to today's topic of discussions, which is money transfer through financial messaging. You probably agree with me that in today's world, a lot of money gets transferred through electronic mode. So you have internet portals, you have net banking, you have all these sites from where you can purchase online. Okay, so since a lot of transactions, a lot of financial transactions happen through this mode, which is the electronic mode, the underlying technology that gets used is financial messaging. So that's why we've chosen today's topic as financial money transfer through financial messaging. I'll briefly touch upon the agenda. We will delve a little deeper into what financial messaging is all about. We have created a use case which is called money transfer through financial messaging, essentially the topic of the webinar. This is a conceptual solution which we are talking about. Of course, it is in place running at many locations, but today we are talking about a concept, not a product. We'll get a little deeper into the logical architecture of this conceptual solution that I just mentioned. Then we'll see what are the USPs of this solution, what are the advantages, and of course at the end we'll take any questions that any of you may have. Moving forward, I am now on page number 3. Before getting into defining financial messaging, I would just like to take a simple business case. Okay, and the simple business case is about a company B which is raising an invoice on company A for some goods or services that it would have provided to company A. So in the traditional mode, company B can create invoice, print an invoice and post it across to in the normal post, and it will reach company A. However, in today's world, there is a possibility that there is a website available which is either created by company A or it's a shared website where this invoice can be uploaded electronically. Okay, so through this website the invoice can be uploaded electronically, and when I say the website, so this upload can happen using typically a HTTPS protocol. Now company A in terms will need to send this payment instruction to its bank. Again, if it doesn't prefer to do it using the traditional paper mode, it can upload this payment instruction into the bank's premises. So there are a couple of options there. Either it can use the bank's internet banking site, or the bank may have provided companies dedicated locations where such instructions can be uploaded through files. So when such instructions can be uploaded through files, typically a file transfer protocol, which is like an SFTP or FTPS, can be used. And if it is an internet banking site, then of course we discussed just a few minutes back. Okay. In turn, the bank A will need to send this instruction to the clearing system. And here we are taking a case where the companies are dealing with different banks, so it makes our case a little bit more comprehensive. So both these companies are dealing with different banks, so it will necessarily require a clearing system to come in place. Clearing systems are typically run by central banks, as is the case in India. There are of course instances where these are run by independent bodies, but here we are taking a case where it is run by the central bank. So for any bank to participate in the clearing process, they will need to follow some standard messaging formats or protocols that are set by the clearing systems. So the bank has an option of, again, either sending these messages in a batch file, which is what is widely gets used in India, or even online. For instance, there's a case of RTGS. Now, before sending this instruction to the central bank, the bank A will debit the company A's account because the money has to be paid from that account. The clearing system, when it operates, it debits the bank A's account and it credits the bank B's account. Okay. In turn, it sends an payment advice to the company B. Again, the mode of transfer could be through any of these standard message formats, about which we will talk a little later in the discussion. Lastly, the company B's bank, which is Bank B, will send a credit advice to company B, which again will be in one of the electronic formats. So what I wanted to, the reason why I wanted to share this business case here is to show that a simple transaction like this, which is just a payment, simple payment between two companies, it requires so many electronic messages, so many financial messages to be transferred, and this involves at least 5 entities, as we have seen in this case. So which is why it becomes necessary to have something, the use case that we are talking about. So I'm moving now to page number 4. There is a description of what financial messaging solution is all about. Essentially what we covered in the illustration below, it tries to describe that. In today's world, the financial messaging solution is an important ask from the banks and other financial institutions, and this is used for transferring financial messages and other financial information. Okay, the key requirement for such a solution is one, that it should be able to support different formats. And the reason for this, I think, is very apparent, because you would have noticed in the last illustration that there are 5 entities involved. Typically, all these 5 entities would use different applications, and they would, in all probabilities, be running different technologies. So hence, the formats are going to be different. So while the banks and the financial institutes are required to support such different formats, they are also under pressure from their respective customers to process these transactions at a very low cost, if not for free. So this is one key requirement from such a solution. In today's world, as we discussed, the electronic transactions, electronic financial transactions are growing every day because of the internet banking, because of all these portals where you can buy goods and services online. The number of transactions are really growing very fast. So there are situations when the bank is required to deal with maybe thousands of such transactions or maybe millions of such transactions in some cases. So there is a need to process as many transactions per day. So that's the second key requirement of such a solution. Thirdly, and quite important, because while we say that different entities will use different solutions and they'll be running on different technology platforms, it is still a very key requirement that all these solutions which are like talking to each other in some way or another, they have some common language through which they can interact with each other. And this language should be independent of the geography or region which they are operating into. Moving on, I'm moving to page number 5, and this is where we're trying to define the use case for MTFM, which is the money transfer through financial messaging, a conceptual solution, as I mentioned. So this is a scenario of let's take a scenario of a bank or a large financial institution. Now, any such bank or financial institution will typically have these applications running. So in today's world, an internet application is something which is available for any bank which is of a certain size, right? So these internet applications have the need to process financial transactions, and hence if a solution like MTFM has to come in play which can support such applications, it will need to support the internet applications. So here, as I talked some time back, typically the interfacing will be through the HTTPS between the internet application and MTFM. Why I'm raising this is trying to suggest here that such a solution will be required to support so many protocols, so many messaging standards. Okay, moving on, ATMs, as you know, I think they are the oldest users of financial messaging. Typically they use ISO 8583 protocol, and they've been using that for a very long time, for decades. So such a solution will also be required to support this protocol, provided the ATM transactions are getting routed through this solution, because there is a possibility that ATM transactions are routed directly by the bank through the ATM switch. SMS gateways. As of now, SMS gateways are primarily used for information exchange and not for financial messaging. So while financial transactions are done by the internet banking applications or the ATMs, and you would have seen this in day-to-day life, that when you do an internet-based transaction, or if you withdraw cash from an ATM, you end up getting an SMS. So while this is a transaction, but it is an information, so it's not a financial message. But in any case, there is a need for the MTFM to interface with an SMS gateway so that it can send this information to the SMS gateway. Core banking solutions. All of us have banking accounts. We'll typically have a saving bank account. Some of us will have current accounts. We will all have fixed deposits. So there is a need for financial transactions to be done through the core banking solution. And I'm sure most of you would have used your core banking accounts through an internet banking solution. So there is an interfacing required between an internet banking application and a core banking solution, and the proposed MTFM solution can play a part there as well. ERP solutions, and this is, most of the corporates, big corporates, they will either be running a SAP solution or a financial solution. So while their own processing keeps happening within this ERP solutions, when there is a time to make payments or receive payments, these ERP solutions are also required to interface with the banking world. Typically, ERP solutions interfaced with banks through file exchanges, and so earlier the files were sent in shared locations and or maybe exchanged through emails. Nowadays, banks and corporates are trying to make it more secure, and they try to use host-to-host solutions. So this is where another protocol comes into play. Legacy systems are actually, you can say they are core banking solutions or extension of them. What makes them really different are that they're quite old. So so they are less open. They typically have proprietary protocols. They will typically work only with files. Maybe some legacy solutions, if they are IBM based, they may be supporting MQ protocols. Okay. At times there is a need to interface with database, because what happens is sometimes some banks do provide some temporary areas in database, and where they expect the financial messages to be dumped, and later on the banking applications pick up the financial messages from these databases. CRM solutions, though not such big users of financial messaging, but there may be situations where these CRM solutions are also required to process financial messages. So what we've seen in this illustration is that in any bank of a particular size, there will be a need of a common solution which is able to interact, interface, talk to many other solutions, and thus be able to process financial transactions. Now what gets highlighted here is that if this MTFM solution, it is really flexible, if it supports all these protocols, and if it supports all the message formats and the file formats that all these peripheral applications are supporting, then the need for changes in all these applications reduces, if not becomes zero. So one of the key USPs, as we talk about later in our presentation, is that the need for changes in the existing banking applications reduces if such a solution comes into play. I'm moving forward to page number 6. Now this is essentially a verbose description of what we discussed some time back while discussing the use case. So I'll just briefly go through this. An MTFM solution integrates multiple independent applications which may be built on different technologies. They may be running on different OSs, different hardware. Okay. MTFM provides an integrated approach to connect different components of IT. So we've seen in a previous illustration that different applications, different people who will be using these applications, different platforms, databases, they are integrated in a secure way, and thus it becomes a collaborative platform within an enterprise. MTFM also enables an organization to integrate business processes internally and externally. So taking an example of a payments business process or a receipt business process or any such examples, there is an end-to-end business process which spans across multiple applications, multiple entities, I would say. There is MDFM also assists in unrestricted sharing of data across all these applications. Now when I say unrestricted, it does not mean that the data is really unrestricted and it can be shared anywhere. There is definitely security measures that are applied and which all these applications have to follow. Excuse me. Moving forward, now I'm on page number 7, which is where you'll see a complex picture. This is the logical architecture of the conceptual solution that we are talking about. So I will take you through this logical architecture. So essentially, if you see, this MDFM solution is divided into 3 key parts. The central piece is the core engine or the central processor, which actually works in the background. Okay, so while this does all the processing and it has all the logics and rules built into it, it is something which is running in the background. What you see at the bottom is the data store, and this data store it typically stores the message and channel configuration data, and we'll talk about this a little later. This also stores the file or the message repository or the message dictionary, and this data store also stores the business rules. So these are used by the core engine. Okay. The third key part of the MDFM is basically the user interface, and the user interface which is used for inquiring, which is used for monitoring, and more importantly it is used for configuring parameters which the central processor then uses. I will now go a little deeper into the central part, which is the core processor, and first cover the core engine. The core engine, we can say it is the heart of the MDFM, which in turn consists of the following components. So you see at the top there is a workflow manager. Okay, so as the name suggests, the workflow manager manages the entire processing within the core engine, which involves the following. Let's take an example of, let's say a message is received from the outside world. So this MDFM is installed in a bank, and it is interfaced with all those systems that we talked about a little while ago. And let's say our message is received. So the workflow manager, it derives which message type has been received, because an external system won't be able to tell what message has been sent. So once the message lands up in the bank, someone will have to figure out what kind of message has been received. So it could be, just as an example, it could be an NEFT message, it could be an RTGS message, it can be a SWIFT message if there are international transactions happening. So it is the workflow manager which derives the message types. Based on the message type, it also decides a specific way of extracting the message. So in a way, it encapsulates the entire data set that is required for processing that message. So the intelligent part that is done by the workflow manager. Again, taking an example, let's say an inward NEFT message is received. Then the workflow manager will identify that it is an NEFT message, and it will pass on that to the message processor. The message processor in turn will create a thread for each message. So I mentioned there parallel message processor, and the reason for that is in real life situation, at a given instance of time, thousands of messages can land up in a bank at the same time. So there is definitely a need for parallel processing of messages. Okay, so it is the message processor's job to create a thread for each message and then pass on this message to the next component, which is mentioned as the message converter, parser, or validator. So this message parser or validator actually takes the message, reads it, interprets it, figures out whether the message is correct, it is genuine, it has all the required information, and then passes it back to the message processor. Now this is where we talked about a situation where an online message has come. On the other hand, there can be a situation where a file is received, and this file may have a combination of hundreds of messages, and out of them 50 could be NEFT messages, 50 could be RTGS messages. So here also the workflow manager comes into the picture. It will first segregate the messages into logical groups based on the message type. So let's say there are only two types of messages, NEFT and RTGS, that have come. The workflow manager will create two logical groups, one for NEFT, one for RTGS. It will then hand over these logical groups of messages to the message processor, which in turn will call the file formatter to validate and convert the message in the desired format. Subsequently, the workflow manager will queue up these respective groups into respective queues so that they can be sent to, let's say, a CBS or the central banking system. Because whenever a message is received from the outside world, ultimately it will get landed up into the CBS system, because some account will need to get credited, some account will need to get debited, and hence it needs to be sent to the CBS system. One of the things which the workflow manager also does is that it sets the priority of the messages. So I've been talking about these two types of messages which are prevalent in India, which is RTGS messages and NEFT messages. Now typically RTGS messages are those which are heavy, which have very heavy value. So there is a need from the customers that these messages are prioritized first. So if a customer is sending an RTGS message and an NEFT message, typically they will expect that the RTGS is processed faster. So that's why the priority setting is also done by the workflow manager. The workflow manager also passes on the channel information and the network protocol to be used, because you'd see on the right hand side that we've listed down a lot of protocols, because if this is a common component which can be used in any banking scenario, then it should support HTTPS, HTTPS, FTP, FTPS, or for online processing TCP/IP or MQ. So it is the workflow manager's job to identify which protocol is to be used, because the workflow manager reads the configuration and figures out that which protocol is to be used. Subsequently, this message is sent to the router. The router then inspects the content of the messages and routes it to the channel based on the content of the message. So the purpose of using a generic router is that the sending application or the sending system does not need to have the information on what routing protocol ought to be used. So this is how the core engine works. Now moving to the next box, which is the operations box. So far we have covered the key components of the core engine. Now we will also see what kinds of operations are possible using this core processor. So there is this box which talks about bulking and unbulking. As I mentioned some time back, there is a possibility that hundreds of messages land up at a bank at a given instance, and all of them may come from only one corporate. So in such a situation, corporates sometimes have this need to combine or consolidate these messages into one single large message and send it across. So this is where the bulking facility is used. On the other hand, there can be a need that a consolidated large message is received, which in turn is consisting of hundreds of messages. So there may be a need to unbundle these messages, and that's where the unbulking facility use. Now the second box which is there is the message failure or action box. Now what happens in this large and disparate ecosystem? There are so many applications, there are so many connectivity, so many protocols. So there are chances that at times some messages do not get processed. So the message may be very genuine and correct, the customer may have balance in their account, but because of connectivity issue or because there may be a system that is down or it is under maintenance, some messages may get failed, and these are parked in a, we can say they are parked in a failure queue. So in this failure queue, then someone can either manually look at these messages and take actions on them, or the MTFN can be configured in such a way that it tries to send those messages again after some time. So this is what can be done. The third box is about exceptions and investigations. Now this is similar to what we just discussed, but the only difference is that at times you get messages which are not correct, which are faulty, which do not have the right set of information, or which are garbled, or which do not have the right format. So if a bank receives such a message, they are parked in exception queues, and again someone can either look at them and try to correct them, or these are rejected and informed to the entity from where they had come. Now, considering that this solution can process literally thousands or millions of messages in a day, it is very important that there is some kind of monitoring which is available. So that's why there are these monitoring features, which could be dashboards, which could be reports or live dashboards, where someone can keep looking at them to just make sure that the processing is happening as expected, or if there are errors happening, then they can probably take some actions. Okay. The inbound outbound routing, we talked about it a little while ago while discussing the router, so I'll skip that part. Another important operation that is part of this core component is the broadcasting and alerting feature. So as I said, sometimes the situation is there that the application is down, so some application may be down, in which case we may want to broadcast a message to all the affected parties, and that's where this broadcasting feature can be used. Alerting, on the other hand, is for specific purpose. So for a individual message or for a batch of messages, if some information is to be sent, whether the message has got processed or whether the message has got rejected, this alerting feature is of great use. Moving forward to the user interface part, the top of the diagram, we talked about it briefly. There is an inquiry feature, there is monitoring, there is message and file management, in the sense that using this user interfaces, the priority of different message types can be changed, or we can configure which files to be processed, which not to be processed. Then there's, as I mentioned, there is a facility to configure different message types and file formats. So there is a UI available where message types, the configuration, the network protocols, and to some extent some validations can also be configured. So this is broadly speaking the logical architecture of this MTFM, which is the use case that we're talking about today. Okay, I'm moving forward from here. So I'm now on page number 8. This is now again a descriptive. There's a description of what the core engine is capable of doing. So it is a complete management of inter and intra banking messages. Then it is a modular and integrated suite. So modular because you see that there are lots of components which are independent. They can be loosely coupled. This core engine, in fact, the entire solution is developed using J2E technology on SOA architecture. It is multi-platform and multi-customer. There is workflow configuration possible. There are database stores available for storing messages and file, and there is online archiving and available, which is for storing and indexing messages. So this was about the core engine. Talking about referring to the user interface, I talked about the user interface. I talked about the message dashboard. And right now, if I click on the message dashboard, there is this sample of a message dashboard which shows in a typical time frame what kind of message execution has happened, how many messages have been processed, how many have been passed, how many have been failed. So there is just one sample. There are so many examples of these message dashboards. So as I said, mentioned, user interface helps in performing the inquiry. It helps in performing configuration actions. Then there is the DB store, which is essentially a repository of the messages or files, and it is also a maintenance of business rules where rules can be created. Moving forward, just summarizing the USPs of MTFM solution. So this solution is a multi-protocol communication are supported. So I talked about it, HTTP, HTTPS protocols for essentially internet-based transaction processing, FTP, FTPS, SFTP for file transfer, TCP/IP or messaging queue for online messaging. The solution is platform agnostic, which means it can run on Windows, it can run on Unix, Linux platforms. There's loose coupling of components, and this is something which is equally important because we're not saying that the MTFM solution should be used in its entirety because there is a possibility that banks may have some of the components already running. So in which case they may require only part of the component. So hence it should be possible to pick up some components and deploy it at the bank and interface it with existing solutions that are running in the bank. So that's why loose coupling is important. MTFM supports both synchronous and asynchronous communication. I'm sure you'd be aware of this terminology. Synchronous is when a message is sent and the sender waits for the response to come back on the same channel, whereas in asynchronous, the sender will send in a message and disconnect, and when the response comes, then it will again pull for the response and do the processing going forward. Now the key components, just to revisit, of this MTFM solution, or the key features, I would say, are message creation. So there is a facility of configuring and creating new messages, new types of messages without actually coding for them. Message broking is a large terminology which includes message transformation from one format to other format, sending of messages, rule definition, and of course message receiving. And as we discussed, notification and alerting. So this is what summarizes the MTFM solution. Moving on to the advantages. Now essentially we've talked about the advantages during the course of time, but just to revisit them briefly, MTFM allows straight-through processing. It of course allows store and forward also, but it allows straight-through real-time information processing. It provides a unified view of application, because though there are these variety of applications that are there, when it comes to messaging, you have one UI, one processor, which does all the job, and all the other applications are not required to do specific tasks. MTFM assists in formation of zero latency enterprise, which means again the same thing, that online real-time messages can be processed, provided the other networks, other applications are available to process them as well. It helps in integration of different applications across different technologies. It helps in quickly putting through business processes. So business processes like payment processing within a bank can be very quickly deployed using such solutions. It helps in creation of virtual corporations, because as I've been talking about it, there are various entities involved in financial message processing. There are disparate systems that are being used, running different technologies, running on different platforms, but the end user gets a common unified view of the messaging. It also helps in interfacing with legacy or proprietary solutions through file processing or other protocols, and it helps in go to market for these applications at a very quick time. So this is essentially what I wanted to cover in this session. Of course, we have I think sufficient time for taking your questions. So I think the moderator is going to forward the questions to me, and then I in fact have a team of experts sitting here which can answer some of the typical questions which I am not able to answer. So over to you, Gaurav.
Thanks, Parag, for such an insightful presentation on financial messaging. Let us quickly take up questions now. I request you to please read out the questions before answering them, so that all our users may get the commendable insights. Meanwhile, I request all my participants to please say questions. So we have got our first question. So request to Parag, please go to the question panel. There you can see all the questions.
Okay.
Are you able to see the questions?
Just a minute, I'm just trying to.
No problem.
Okay, so one question which I can read here is it related with IMPS? Okay.
Yeah, perfect.
So yeah, I'll let my senior architect Jaspreet, who's here with me, answer this particular question.
Is it is it related with IMPS IMPS is one part of it. It is so here we are talking about all kind of a messages. It is not limited only with the IMPS. It could be your basic protocol, messages gateways like RTGS, NEFT, ECS, SWIFT network, private networks of the bank. So it is not limited to IMPS. It is beyond that. So it is capable. This particular system is capable of handling all kind of messages.
So only thing I would add to it is that IMPS is just one of the protocols, and this solution supports so many others. Of course, IMPS is one of the latest one, which is now getting very popular.
So next question.
Okay.
Mr. Parag, are you able to see?
Just trying to access the question. The window is very small.
You just double tap on top of it.
Double tap, is it?
Yeah. Is it
Yes.
working?
Another question is, does it ISO 8583 also fits in here? So, as Prayag already mentioned in his presentation, that we are capable of integrating with all the ATM systems, right? So ATM usually do a financial messaging through ISO 8583 standards. So this particular solution is pretty much comfortable, and we have already implemented in one of the bank where they are using ISO 8583 standard.
Okay. Push here. Okay.
Yes, another question, the application is developed for nuclear system. Yes, it is developed not for the nuclear system. It is basically for any system who needs an integrated. It is just like a homegrown enterprise service bus where a lot of integration is required with among the various systems which are running on different platforms, right? So we have built a messaging gateway where different systems of the bank or outside the bank can communicate with each other. It's basically a component which can be used by any of the parties which need such kind of a messaging environment.
Okay. Like capable to handle for overflow. There is a question which says, is it capable to handle buffer overflow kind of difficulties? It's not very clear.
Okay, so if I understood it rightly, so basically buffer overflow. So whenever the two systems talk to each other, there is always a contact between them. So those specification has to be freezed whenever any messaging handshake happens between the two systems, right? So there, I don't think so. So programmatically, if you have handled everything, the contracts, so there is no question of buffer overflowing here, right? So basically, so when the contract is met, so if the message or the file which we have received is not as per the contract, basically we will fail those messages and park them into exception queue to take an action by the bank users or the intended users of the application.
Okay, so next question says, how will it validate the message content?
Okay, so validate the message content. Basically, message content, because various standards are there, like ISO 8583. They have their own standard of handshaking between the two systems, right? So when any 8583 message is being received, so MTF first validate that message against that specification, whether the right specification is there. So based on the type of message, if it is XML message, then it could be validated through an XSDs, or if it is a fixed file format. So based on the contract, these messages are getting validated. So there is another question: can this system used by a corporate who uses a ERP system to communicate with bank or receipts and payments? Yes, this can be used by the corporates, but so basically in the start, so we Prag has already mentioned in his presentation. So this system is capable of talking to ERP systems of the corporates, or corporates can prepare their files or payment requests or invoice. This system has interface, web interface as well, where corporates can directly push their files using that interface to a bank, so for the further processing of those payments and invoices. So it can integrate to an ERP system using an SFTP protocol, where the ERP system, whatever the file formats ERP system is generating, so we are capable of reading that file in their format like IDOC. So there are various separate file formats which are standard available from the ERP systems. So this system is very much capable of reading those types and processing and sending the converted message into a intended software.
So Mr. Prag, till now we have received those many questions. I request all our participants, if they have any query related with the topic of the webinar, they can say it with us. Mr. Prag, we have just received one more question from our participant, Mr. Assis. Can you please go to the question panel and take this question?
Scroll up. So can MBizBizTalk be used as a message broker to virtual integration, which can sit at top of the system?
So the question is, can Microsoft BizTalk be used as a message broker to have integration which can sit at top of FMPS system?
Yes. So we have built in a capability where, if bank already is using their enterprise service bus or any other broker system, so they can use it. It can sit on top of it. So we are capable of giving them the raw data as well as converted format of the messages to any enterprise service bus.
I think we are done with our question and answer round. So I request all our participants, if they have any question, you can visit to our website, that is techgeek.com, and you can post your question there if you have any question regarding the topic. So Mr. Parag, I'm really thankful to you for conducting this webinar and taking so many questions. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of this webinar will be available on our website, that is techgeek.com, by tomorrow. Thank you all. Have a nice day.
Yeah, thank you from our side also. Thank you very much.
Thank you, sir. Have a nice day.